Okay, I think these questions should be more straightforward. All right, so we're going to work out the rate equation and the rate constant at the particular temperature. So we look and we want to know, so we're going to know that rate equals K, A, B, and then all I need to do is work out what the exponents are here. And that could be 0, 1, or 2. So let's look at the data. So for A, from 19 to 20, I go 1 to 1, there's no change. Brilliant. Okay, so I can use that to work out what the order is for B. So B times is by 2, and the rate is multiplied by 4. Okay, so I times the concentration of B by 2, the rate goes up by 4, which means that B must be second order. All right, because I've got a change in B and I've got double that change in the rate. Okay, so now this question is quite easy because now it's given me the B stays the same as well. You won't necessarily get that in the remaining questions. Okay, here they're not so kind to you. So these ones stay the same, but these don't stay the same. But anyway, let's go back to this. So here there's no change. Okay, there's no change here, and this doubles. All right, so any change here will be entirely due to A, and I get A times by 2. So this is times by 2, this is times by 2, which means that the order with respect to A is 1. Okay, so I have now the rate equation is, I'll write it out again neatly. So for the first one, K equals A B squared. Oh, no, sorry. Rate equals KAB squared. Okay, so that gives me the rate equation. Now I want to work out the rate constant, including its units. Okay, so let's do that. We'll do that up here for the first one. So I can rearrange the equation. So I have K equals rate divided by AB squared. And now all I need to do is I can just choose any of these rows and just input that data into my equation. All right, so let's just choose the first one because that's nice and easy because these are all ones. So my rate here is 2 divided by the concentration of A, which is 1, concentration of B, which is 1, which gives me 2. And then all I need to do is just work out what the units would be. So if I have rate is moles per decimeter cubed seconds to the minus 1, divide by, well, I've got 3 concentrations there, haven't I? So I've got moles decimeter cubed. So I can cancel one of those, which is going to give me seconds to the minus 1 divided by moles squared decimeters to the minus 6. I'm taking the reciprocal of this, so these are going to change sign. So it will be moles to the minus 2, decimeters to the 6, seconds to the minus 1. Okay, now it's important to understand that for this part, I use this first row here. Now I could quite easily have used the second row or the third row, but it doesn't matter because it would always give me the same answer. Now you can check that yourself, and it's important that if it's not immediately obvious to you that would be the case, you need to have a little think about that. All right, because the rate constant is a constant. As long as the temperature stays the same, then changing what the rate constant does is it relates the rate to the concentrations. So the rate constant will always be the same regardless of what change you do to the concentrations. Okay?